This question asks, what is the IUPAC name of the following molecule? So in this case, we have a molecule that has a ring, and we've also got kind of two different functional groups. We have an alkene and we've got a ketone. And so we've got to figure out here which functional group has the highest priority. Right? So if we think about that, the carbonyl compound, the ketone, will have higher priority than the alkene does. So that again just kind of goes back to the hierarchy of functional groups in naming. Anytime you have a carbon to oxygen double bond, they are typically going to be higher in priority than things like alkynes, alkenes, alcohols, etc. So that's super duper important because again, it helps us figure out what is the parent name and where do all the locants go. So in this case, we're going to next look for what is the longest continuous chain of atoms that the highest priority functional group is attached to. And in this case, it's attached to a ring. So that means that we kind of put the one position right here. And in this case, we have a 6-carbon ring. And so our parent name is going to be cyclo. It's important to have the cyclo to indicate the ring presence. And then hex. The hex is indicating that it's a 6-carbon ring. The rest of the name is going to depend a little bit on the functional groups that we have. So let's turn our attention to what is our parent chain, our parent functional group. We have a ketone right here. And then all ketones end in ONE. So that's kind of just the hallmark of the suffix used for ketones. But we also have to keep in mind that we have an alkene present. So alkenes can be denoted in the parent name as well with an EN. So here we would have a number here for the location of the EN and an ON. So the ON is for the ketone. The EN is for the alkene. We don't need to put a 1 in between the EN and the ON. The reason for that is because whenever you have a ring, it's always assumed that the highest priority functional group is at the 1 position. And that's just kind of a rule of having a functional group on a ring. So we don't have to add the 1 in front of the ON. So a couple of questions that we still have are, there is a functional a substituent here, a methyl, and we also kind of need to know what is this number, because you have to indicate where that pi bond is located within the ring. So we have a couple more things to kind of flesh out, but now we kind of know what the parent is. It's a cyclohexenone, right? So next, let's kind of think about the locants. Whenever you're assigning locants, the goal is to have the lowest possible locants. So if we think about the one being where the carbonyl is located, we can kind of number 2 different ways. We could go counterclockwise, or we could do the opposite and go clockwise. If we go counterclockwise, the locants that we'll have are 2 and a 3. The 2 will be for the alkene, the 3 will be for the methyl group. If we go clockwise, we would have a 5 and a 5. So you're always going to be looking for the lowest possible locant. And so that's why we go counterclockwise here so that we can have the lowest possible locants. All right, so we know that this should be a 2 in front of that EN in order to indicate where it's at. And then we have that methyl group on the 3. So we can add that in, 3-methyl cyclohex 2-EN-N-ON. All right, when you're naming the alkene, you don't have to put locants on both carbon atoms of the pi bond. You just need the first one. That's why we use 2 in the parent name. So let's take a look at our answer choices. There's only 2 that start with 3. And the only one that makes sense based on our parent name that we talked about is answer choice B. D doesn't work because it treats the carbonyl of the ketone as a substituent, which it's not. It's kind of the key functional group of the parent. So the parent would be like the cyclohexenone, and then we add the EN in for the pi bond. All right, so in this case, we kind of had competing functional groups. We had to figure out which way to put the locants, and then how to put all of the name together. So again, the answer choice should be B based on that discussion.